This is the lesson for Chapter 5, Section 8, identifying combined transformations. And so what we're going to look for is we're trying to see what the sequence of transformations is. Sequence means what ends up happening. So remember, we've got some rigid transformations, and those are listed up here. Translations, which are moves. So if the item was moved either left, right, up, or down. A rotation is when it was turned. So if it turns, or reflection when we flip it. And so the other type is a dilation. And this is when the size changes. So those are the different things we're going to be looking for as we do these. Now note that the way I end up doing it is not the only way. So here, answers can vary. And so what that means is there's lots of different possibilities. And I might give one or two possibilities when I'm doing these problems here. So let's take a look at our first one there. And it says identify a sequence of transformation that will transform figure A to figure B. So let's take a look at what's happening here. So first of all, I see that it is flipping. So a flip means I end up reflecting it. And then after I flip it, though, it looks like it moves. So if I'm here at A, and if I flip it over the y-axis, it would be right here if I reflect it over. But then it moves one space to the left. And so flip and then move. And so that's kind of the general gist of what I want to do. So now I'm going to write that out a little bit better. So basically what I'm doing is I can reflect across the y-axis. And then translate 1 unit left is what I'm doing. So notice how it goes 1 unit left. So what that would look like is this. If I started at xy, that's what I start with, then what it goes to is it goes to a negative x, comma, y. And so what that means is that the x value is going to change, but the y value is going to remain the same. Notice that all the y values here are all the same. It's just the x values just get switched from positives to negatives in this case. But then it's going to do something again. Then what's going to happen is I'm taking these values that I have at negative x, and I'm going to take away 1 from that. And then I'm going to also keep the y value the same, so that doesn't change at all. So that's my formula that is happening, and this would be the word phrase. Now there's something else I could do. I could have said maybe translate first. Maybe I translated it back 1 space. So I could have translate right 1 space, then reflect, and reflect across the y-axis. And so what that would look in formula form would be this, x, comma, y, and then it went to, well, then I went to the right 1 space, so x plus 1, comma, y. But then after that, I changed it again. I ended up reflecting it. So again, I went right 1 space, this way 1 space, and then reflected it about the x or the y-axis, so it'd go like this. So the x value ended up switching signs, so it becomes the opposite of x plus 1, and then y values stayed the same. So this is what it would end up looking like. So again, that's why I'm saying answers can vary. There's lots of different variations of this, but from here on out, I'm just going to give one form of the answer. So this next one, when I look at this, I see it's rotating. Notice how it rotates. Now I could rotate it this way, or I could end up rotating the other way and eventually get to the same spot. But I'm going to go with this way. I'm going to go with the rotating to the left. So it's a turn left. And so whenever I turn left, that's counterclockwise. And it's only 90 degrees it turns. And so let's just take a look. And sometimes it's nice to be able to move the figure to be able to see what's happening. So let's take a look at this point right here. This was the original because it goes from B to C. And B was, or this point here, is at 2 spaces left, so negative 2 comma 1. So that is that point. Now if I took that same image, and I've got a picture of it over here, so let me go ahead and pull it up. And so if I look at this image right here, this was the original one. Let's see, it was this one right here. And I go ahead and take that image, and let's go ahead and rotate that. So let's see if I can do that on this. So I'm going to rotate it counterclockwise 90 degrees. Okay, so let's do that. So here it is. Okay, so there's our figure. So this is that new figure. Let me go ahead and trim this out. And so let me try that once more. So this is my figure here, and let me paste it onto my drawing that I'm doing. So we'll do a Control V, and here's the image. So let's see what ended up happening. This was the original one here, and this is what it turns to. And again, as you turn the page, you can actually see this yourself. And so we're going to go ahead and take a look at what that point's going to end up being. So if I look at this point right here, this is that point that I was talking about. That is 1 space left, 2 spaces down. So basically what it's going to is 1 space left, so it's negative 1, and 2 spaces down. So notice that the formula for this goes from x, y, and then it goes to this. The y value becomes the x value, and it becomes opposite sign. The x value stays the same. So it wasn't negative 2, and it stays at negative 2. So this is the formula that we ended up doing. So this is where we end up being, and then from there, let's see what happened. Well, it went from this point right here, and it goes up to this point right here. Goes up to that point right there. And so that means that it had to go over 1 space to the right, 2 spaces up. So basically what we have is 1 space right. So 1 space right. So we got negative y, and then we added 1, and then we ended up doing this. We went, that is the y value, and the x value, we went up 2 spaces. So that's what we ended up doing. So that's the formula. So let's go ahead and just write it in words. So basically it was a rotate counterclockwise 90 degrees, then translate 2 spacers. Let's see, it was 1 space right and 2 spaces up. Well, let's take a look at another one here. So this next one also looks like it has a turn. So I could either turn it this way, or I could have turned it to the right. So we did a turn to the left last time. Let's go ahead and do a different turn. Let's go ahead and say it turned this way instead. So we're going to go with a clockwise rotation of 90 degrees. So it went into this region here, and I know it only turned 90 degrees because look at the way it's facing. If it turned 180 degrees, it would be facing the same direction. So this way, it would be the long way going this way, but it's not. So I knew it only turned 90 degrees. So let's take a look at what that would actually look like. And so again, it's nice to be able to take your own paper and turn it. So since I can't turn the computer screen, I'm going to have to go back up to the image that I originally had. So let's go ahead and take this image, and let me bring it back to where it was. And so we're looking at this one right over here. So we're going to take that image, and I'm going to turn it clockwise 90 degrees. So now it's this one right in here. And so let's go ahead and trim it, clip it, and I'll paste it. And this is it. So let's see here. It was originally this one, but so this is what the original image is, and this piece right in here, just this piece right here is what I'm looking at. So let's take a point. Let's take maybe this point right here, and it got rotated, and when I rotated, it went to this spot right here. So this point is 1 space to the left and 2 spaces up. That was the original XY value there. And what it went to is this, 2 spaces right and 1 space up. So the rotation, when I go clockwise for clockwise 90 degrees was this. It goes, the y value becomes the x value becomes the y, and it switches signs. So if you don't remember this rule, then just look at a point and see what ends up happening. And then from that point, you'll be able to figure out what the rule is. So that was what happened there. So that's to start with. So let's write that down. X, y, and it went from to y negative x, but then let's see what else happened. Then it translated. See, this is where it is now. And so this was the original, so we're kind of avoiding that one. Look at this one here. This is where we were after the 90-degree turn. So this is where it is. And then it got moved down 1, 2, 3 spaces. So then it went down 3 spaces. So the x value stayed the same. So let me rewrite that. Remember the x value is now the y. And the negative x here, the opposite of x, we end up having to go down 3 spaces. So that's what that value ends up looking like. So I'll put some parentheses around that to show that's an expression. So that's what happens. Let's specify that in words. So it was a rotate clockwise 90 degrees, then translate 3 spaces down. So again, this is just one way of specifying what ends up happening to it. You could also say other things. I could have rotated it counterclockwise, and then I'd end up having to move it 3 spaces to the right rather than down. Well, let's take a look at the next one. Notice this one goes from A to B. Notice it's changing in size. So size changes. So whenever we change in size, that means we're dealing with a dilation. So let's take a look at what's happening. Let's look at the length of this side. This side is 2 units by 2 units. So now it becomes 4 units by 4 units. And so when we look at scale factor, when we're talking about dilations, we're looking at scale factor, and it changed from a new over the original. And the new value ends up being 4. The original value was 2. So the scale factor is 2. And so what we're going to end up doing is we're going to take a look at what else ends up happening. So our scale factor is 2, and that's our dilation, and then we end up taking a look at what happens. So let's take a look at a point here. Let's look at this point right here and compare it to this point where it's at. So this point is at negative or 1, comma negative 1. So if I end up doing a scale factor of 2, that means that I need to double the x value, and I need to double the y value. So this is what it becomes. It becomes 2 and negative 2. So that means this point here it should end up being 2 spaces to the right and then down 2 spaces. So it should be right here. But it's not. It's way up here. And so what happened? Well, it looks like it went up. Actually, this even shouldn't be it. Remember, I was at this point. This point, it's where it should be. This is where it is. And so it slides right along this line here. And so where does it need to go? Well, it needs to go 4 spaces to the right. See, 1, 2, 3, 4 spaces right. So 4 right. And then it needs to go 1, 2, 3, and actually it was right here. So 1, 2, 3, 4 spaces up. So it was here, and so it went 4 right, and then 4 up it needs to go. So that's what it translates. So we'll have to say that it goes, we'll say that it dilates the figure with, or dilate the figure, we'll say. That sounds a little better. Dilate the figure, singular here, not plural. So dilate the figure with a scale factor of 2, then translate 4 units, so 4 units right, and 4 units up. And that would be our answer for that problem. So those are the types of problems you're going to see on tonight's homework. Good luck.